Hello, everyone. Good morning. Thank you so much for joining us today for the Clean Coast Texas Lunch and Learn series. My name is Christina Lopez, and I apologize if you hear the train in the background right now. I'm at the Meadow Center for Water and the Environment at Texas State, and I'm the Coastal Coordinator. We are going to get started today with some housekeeping items. I will then be introducing Jason Pinchback, who will then introduce our speaker, Dr. Felix. All right, so please remain on mute. That will really help us with sound quality. Please be aware that this meeting is being recorded. And we are going to be using the chat function today. If you would like to introduce yourself, feel free to do that right now. You could share your name, your organization, and maybe what brought you to the Lunch and Learn today. And then you can have the video on or off, your preference. Right, so like I mentioned, I will be introducing Jason Pinchback in just a few minutes, and he will be giving an overview of Clean Coast Texas program. My name is Christina Lopez, and I work very closely with Jason and others in our collaborative. Also working alongside us today from the Meadow Center is Anna Huff. She's going to be our tech support today. Anna, would you like to introduce yourself really quick?
Hi, happy to be here.
Thanks so much for your help. We sure appreciate it. If you are having any technical difficulties, please feel free to chat Anna directly. All right, so again, some housekeeping items. Please remain on mute for the duration of this event. Please use the chat function to introduce yourself with your name, your organization if you would like, and also maybe what brought you to the Lunch and Learn today. This meeting is being recorded, and we will have the recording available for people who might have missed out to view at a later date, so please be aware of that. And then video on or off is your preference. All right, I would like to go ahead and introduce Jason Pinchback from the Texas General Land Office. Jason?
Thank you, Christina, and good morning. Welcome to the Clean Coast Texas Lunch and Learn series, where we unpack coastal non-point source, water quality, and related issues along our Texas coast. Clean Coast Texas is sponsored by the Texas General Land Office Coastal Management Program. We're working with coastal communities to address and resolve local non-point source and water quality concerns through a number of different practices. To be responsive and being able to adapt to the different local concerns, we partnered up with Texas State Meadow Center for Water and the Environment, Texas Sea Grant, Texas Community Watershed Partners, and we offer a variety of services in something we call our menu of services that'll be in the chat box in just a second. We've also packed our website with a lot of different resources targeting both the general public, elected officials, as well as developers and engineers. So please visit our cleancoast.texas.gov website to check out some of those resources after our event today. We have an exciting program where we're going to be exploring nitrogen. And if you're not familiar with the topic, you will be a lot more familiar by the end of the day, as we are featuring Dr. Felix today from Texas A&M Corpus Christi. Dr. Felix is an associate professor of chemistry in the Coastal Marine Systems Science Program Coordinator at Texas A&M University-Corpus Christi. His primary research investigates the exchange and interactions of pollutants, specifically nitrogen species, across the biosphere, atmosphere, hydrosphere, and geosphere. His research group applies stable isotope techniques to characterize nitrogen pollution sources and processing and investigating human impacts on the nitrogen cycle and associated ecosystems. He has applied these techniques to research collaborations worldwide, but has recently focused his work to regions of the Texas coastal bend to help improve local air and water quality. The information provided by his projects guides emissions reduction, pollution loading mitigation, and watershed restoration plans throughout the coastal bend. We're also working with Dr. Felix right now on a study and investigation looking at bacteria in relationship to septic systems in the Texas coast. We're very excited to feature Dr. Felix. Welcome.
Thank you, Jason. And thank you, everybody, for joining me over your lunch to talk about some of our projects looking at nitrogen loading into our coastal bays waters. So first, this work is not just me. I'm a very, very small part of it. So I would like to acknowledge the funding partners, which is TGLO and the Coastal Bend Bays and Estuaries Program. Some of the principal investigators, Dr. Wetz, Mergelet, and Abdullah. And then really the students who make this, all these projects really move. The top two, Aaron and Yishi, I'm going to introduce a lot of their work today, but a lot of this work stems off of Jackie Campbell's work from a couple years ago. She's at the Texas Water Development Board now, so some of you may know her. So we'll start out very simple. What do we mean by nitrogen? We need nitrogen. We need nitrogen to live, and it's 78% of the air we breathe. But this isn't the nitrogen we're talking about when we talk about loading. This nitrogen is not bioavailable because of this triple bond. We are talking about bioavailable reactive nitrogen. And in the waters around here, we're talking about dissolved inorganic nitrogen, meaning nitrite, nitrate, and ammonium. And we also are talking about organic nitrogen. It does not seem to get as much attention, but its attention is increasing. And these dissolved organic nitrogen compounds, you can think of them as any nitrogen that is bonded or attached to carbon. And there are thousands and thousands of compounds. And for the purposes of this talk, we'll talk about them as a whole. So why do we care about nitrogen loading into our coastal waters? Well, first we need to start out with, where does this nitrogen come from? And when it comes to our waters, this changes in significance depending on where we are on the coast. But we want to think about wastewater outfalls and septic systems and deposition from the atmosphere, fertilizer, and livestock waste. And then we can have these sources load into our waters from the atmosphere or from surface runoff or rivers or from groundwater discharge. So we end up with these sources adding nitrogen into our systems. And the way I usually think of this, I don't think of the sources, I think of all the dissolved species of nitrogen that we are now loading into our coastal waters. And this can cause eutrophication, decrease our water quality, but also can lead to primary production because different organisms like algae are going to uptake these different nitrogen forms and lead to algal blooms, including harmful algal blooms. But these blooms do die. When they decompose, the decomposition eats up all the oxygen in the water, leading to hypoxia. Also, these harmful algal blooms can give off toxins. So this leads to death of aquatic creatures, including fish kills. So all bad stuff for us. And this isn't just a local problem. If you look at this global map, you look at the distribution of eutrophic coastal marine systems, and you see it's a problem across the globe, especially in these developed areas, these developed countries, where we are making nitrogen and loading more nitrogen into our coastal waters. For instance, 78% of US coastal waters have these eutrophic symptoms, and 66% of Europe's Atlantic coast waters do. But let's bring it back home. So we're looking at two cases in the coastal bend today. One's going to be Baffin Bay and Laguna Madre. And what you'll see here is that this part, if you look at the figure with total keldal nitrogen listed, you see that nitrogen in Baffin Bay down here, you can see my pointer hopefully, has high levels of nitrogen, especially compared to the rest of the coast. And this nitrogen leads to the proliferation of brown tide, as does some other physical factors in the water. But this leads to declines in seagrass and benthic invertebrate populations, which also then affects the fishing industry, both recreational and commercial. We'll also discuss another case on the Gulf Coast rather than in the estuaries from Galveston to Matagorda, where there has been high fecal indicator bacteria. And you can see that from this graph that recently it's been very high in this Galveston to Matagorda area. And Jason just touched on this project. It is ongoing, but in this region also, we see red tides and fish kills in the past. And these tides or these algal blooms can feed on nitrogen. And also fecal indicator bacteria also is an indicator there's probably nitrogen loading in these areas. So let's start with Baffin Bay. And real simple, Baffin Bay, really high nitrogen levels, but most of this nitrogen is organic nitrogen. And the levels are very high for our coast and also compared to global coasts. So we know that organic nitrogen is also something that helps brown tide proliferate. So it was the focus of my group's early studies was to look at where this organic nitrogen was coming from. And these studies started in 2016 and really piggybacked off the volunteer stakeholders down in Baffin Bay, the water quality group that Dr. Wetz at TAMU-CC was organizing, where they looked at these high concentrations of nitrogen. And my group came in to help trace them. And this was at 6 surface water sites to start out. And then as we kind of realized that maybe the culprit was septic waters, we did a preliminary study, or septic systems, we did a preliminary study at 2 sites in the bay. And you see those 2 sites here. One right at the fishing pier in Riviera, and one in an undeveloped area in Baffin Bay. And you can actually see if we zoom in on where the fishing pier is, the fishing pier has a public bathroom with a septic system. And the septic drain field here, you can see is not necessarily working because of these green lines. All this nitrogen should be processed and not really leaching out so the end of the soil so these plants can use it. But you can see where this drain field is. And then to build on these preliminary studies, we just finished up all this sampling on a much larger scale study across the whole watershed. So I'll look at just some summary results so far. Again, we wanted to get at these organic nitrogen sources. 95% of the nitrogen in these bay waters, surface waters, is organic nitrogen, and we think it's feeding the brown tide. So we look to the primary sources. We look at wastewater, wet deposition, fertilizer, and livestock waste. We have to find a way to start tracing these sources. And one way my group does this, and there's other ways of doing this too that are complementary, but one way my group does it is to use isotopes. And I won't go into detail here, but I hope that I can get across the idea of how we use these isotopes. So for nitrogen, what we're sourcing, all nitrogen has 7 protons, but there are 2 forms of nitrogen in our different sources. One has 8 protons, one has 7 neutrons, and each source has a ratio of these heavy to lighter nitrogen. And that ratio is specific to our different sources. And we end up reporting them in per mil. Keep in mind, this isn't percent, it's per mil, so we can report these ratios in closer to whole numbers. So we characterize these different sources with these nitrogen isotope ratio values. And you can see they're all different from each other. And you can think of them as different fingerprints. Once we have those fingerprints and understand how all these sources are different, we can take a sample of the bay water. And what that's really representing is all the sources combined in one. But we need to know how much is contributing to this bay sample. So we use a Bayesian type mixing model, which is represented here. And we can start to estimate where the nitrogen is coming from, specifically this organic nitrogen. So you can see here at that, those two site project, one near the septic, one away from the septic. If we average that over the whole year, and we look at the bay water as a whole, close to the coast, we see that the majority of our nitrogen is coming from wastewater or septic, and the other three sources are still significant and close to equal to each other. Now, we also continued to sample at 6 different sites over an additional year across the bay, not just near the coast. And we thought to ourselves, well, we could sample in dry and wet conditions, and we should see a change in these sources, right? You have more wet conditions, you should have more runoff, maybe from fertilizer and livestock waste. And obviously, your rainwater input should increase. And we do see that. During the dry times throughout the bay, we see more septic. But then in the wet times, we see that the wet deposition or rainwater takes over as a DON source. Now we started to think of septic and wastewater as our large source. So where is this coming from? And we know that the feeder creeks going into Baffin Bay, they don't really run all the time. There's not always a constant flow of these feeder creeks. So we wonder, well, does that mean that the wastewater outfall that are up these creeks can't really be reaching the bay because there is no flow? But in this area, it's mostly on septic rather than the municipal wastewater. So we know there's septic systems throughout here. So I think that's another place where we can get wastewater into the bay. And that septic system then would leach into the groundwater. So the actual delivery mechanism would be from the groundwater. So we put in about a dozen monitoring wells. And when we look to the monitoring wells, the nitrate concentrations in these are very high. Just for reference, Baffin Bay surface is about less than 1 micromolar. Corpus drinking water is about 32. The EPA maximum contaminant level is 726, and the Baffin Bay groundwaters average about 970 micromolar and are as high as 7,300 micromolar. So these are pretty high. These are sufficient groundwaters. So where is this nitrate then coming from that is reaching our groundwaters? And we can take another approach here where nitrate has another isotope, oxygen. So we have another fingerprint, and we can add these fingerprints together to see where our nitrate is coming from in the groundwaters. So if we plot the groundwaters on this plot, so these are samples from the groundwater and their nitrate isotope compositions, we see that most of it falls out within the sewage or septic range, something we think is probably attributed to ammonia coming from septic and then being nitrified and denitrified in the groundwaters. So we look at Baffin Bay, and in summary, we see that there are many sources reaching Baffin Bay, and maybe this septic and sewage type source is our main culprit, which leads us into the next project, which Jason mentioned, where we're looking at nitrogen loading into the Gulf of Mexico from Galveston down to Matagorda. So you can see this area here. And some of you may be familiar just looking at this map and the features here. But we again have well samples, and then we sample pore waters and surface waters here monthly. And we just look at the simple results right away, and you see that this environment is very different than Baffin Bay. Baffin Bay is a long residence time, reverse estuary, but now we're getting into the barrier islands in the Gulf Coast. And whereas we had a lot of DON in the surface waters, now we have about 50-50 nitrogen to organic nitrogen, or inorganic nitrogen to organic nitrogen. Also, the levels of nitrogen in the Gulf of Mexico are about a quarter of that of what is in Baffin Bay. Then you see in the pore water and the groundwater, we have a lot of inorganic nitrogen, but this really doesn't give you an idea of how much is there. Neither does this graph probably, but this is how it looks over time. And it's the different forms of nitrogen, inorganic and organic, over time at all of those sites from Galveston to Matagorda, surface water, pore water, and well water. And what I will point out here, we'll look more into in the next couple of slides, is that the well waters are on a different scale because they have much higher concentrations of inorganic nitrogen. So if we just zoom in on this data and we just look at the wells or the groundwater, and we have about a dozen of them. These are wells numbers down here on the bottom. And then the colors are the different inorganic and organic nitrogen in these wells over that time period, about 10 months that I have data for. And you'll see that ammonium is almost always off the charts here. And then sometimes we even have nitrate that's very high in these systems also. So when we think of ammonium in well waters near septic, when its effluent comes out into the drain field is mainly ammonium. So it's possible that this ammonium is not being processed and is reaching these groundwaters, but it's also possible that these well waters are also reflecting something similar to pore waters in the back bay. We're still investigating that. But we can look at is that we see these different well waters, which are highlighted here in these boxes, where there's high ammonium, there often is high nitrate. So the red and the blue together. So we think this ammonium likely being converted into nitrate. So we can take a look at the nitrate again on our plots. And if we look at the groundwater, again, it falls down towards the nitrate that is from sewage and septic. Whereas we look at the surface and pore water, maybe not so much. So maybe there's transformation before then. When we look at the ammonium, you want to look at ammonium as also a source, and these high isotope ratio values can point towards septic and wastewater and these high concentrations in the wells, but you can't really say that because there's a lot of transformation with ammonium, which also masks this signal. So we need other avenues to complement this data. And then something that's maybe a little outside of the scope of this work, but I like to point it out, is that we can look at this nitrate isotope data, and we can actually look at how the nitrate is being processed throughout the system. So this is the same graph really, but instead of looking at the sources, we look at how the data points are trending. And we can actually then look at how they are plotted against the natural log of their concentration. And this is just in this surface water. So I'll go back again. This yellow data is the same as this yellow data, but plotted against the natural log of the concentration. And we can start to see that in the wintertime, in the water column, is a time when this nitrate is becoming assimilated or taken in by primary producers. And these processes, when we can start to really nail these down, we can start thinking about when these primary producers or when these algal blooms are happening and what type of nitrogen that they are actually using. But that is for more investigation as we move through this project. So we see we have a number of different nitrogen forms in our different bay systems, Gulf of Mexico systems. We have inorganic nitrogen like nitrate, ammonium, and organic nitrogen. And the significance of all of these changes depending if we are in the groundwater, the pore waters, or the surface waters, or what environment we are, where we are in the coast. So depending on where you are, you need to decide what is the most cost-effective, what is the most efficient way of decreasing this loading into our coastal waters. So we can look at this on a large scale, an industrial scale, like wastewater treatment plants, making sure that these are up to code, the best technology available. So we're taking the nitrate or the ammonium or the organic nitrogen and we're processing. Ideally, you want to process all into the nitrogen gas that's all around us. That's 78% of the air. It's not harmful. It goes right back into the air. And that's the best case scenario. Also with fertilizers, there are times of the year that are better for applying fertilizer, whether it be wet and dry seasons, that will reduce the risk of actual loading into the groundwaters or runoff into streams. Speaking of the runoff into streams, we can start to repair some of our riparian zones. Riparian zones are just really these areas beside the streams where there's vegetation and there's all kinds of good bacteria and organisms in here along with the vegetation that will actually convert a lot of this nitrogen into non-harmful forms like N2. So before it reaches the actual stream and can be loaded into our waterways, these riparian zones, if they are rebuilt in their natural conditions, can start to process a lot of this nitrogen. You can also look at our livestock storage. You may have seen these types of slurry ponds over here on the right. And what's important about these slurry ponds is that they don't leak. If they leak, and these are very concentrated forms of nitrogen, then it's going to leak into our groundwaters, leak into the groundwaters, leak into our coastal systems. There's also, when you have these open slurry pits, you can also have emissions. And there are ways to combat these emissions, like ammonia volatilizing directly out of these slurry pits. And I talk about these emissions, I'm going to talk about them more because we often think about the coast and nitrogen loading, and we think about rivers and groundwater and pollution directly running into it. But whatever we emit into the air also comes down as dry or wet deposition. And we emit a lot of nitrogen into the air, whether it be from our vehicles or from farming or from power plants. So emission technology is also important. For instance, when it comes to power plants, we have very high emission technology now, including selective catalytic reduction, where we can really reduce about 95% of NOx coming out of power plants. The issue with this is it takes ammonia to do this selective catalytic reduction. And if it's not done properly, then you have ammonia, what we call ammonia slip, leaving these emission technologies. The same goes with our three-way catalysts. We have reduced a lot of our NOx emission. NOx emissions go into the air, they become nitrate. The nitrate comes back down into our coastal waterways. But we've reduced a lot of that with three-way catalysts. The problem with this, a byproduct again, is ammonia. And ammonia is just as bad as NOx when it comes to loading of nitrogen. So these emission technologies are great, but they need to work properly. So we need to maintain them. Also, we could go to non or low emission energy sources. And also, during the spring, sometimes you may notice, depending on where you live in Texas, that we have a lot of particulate matter or smoke coming down or up from Mexico and Central America due to slash and burn techniques. All of this does carry with it reactive nitrogen or bioavailable nitrogen. So we could reduce these techniques also. But that's on a very large scale, and a lot of us don't have control over these things. So what can we do on an individual scale? A lot of the Texas coast has septic systems, and there's no real regulations on individual or residential septic systems. So it's kind of up to the owner to maintain these systems. And I think there are programs now to help with the cost of this, but it's important to maintain these septic systems. They can be a very important concentrated source of nitrogen into our waterways, especially if your soil is very permeable and it's maybe sandy and you don't have a lot of processing of the nitrogen once it gets out into the drain field. Also, simple things like picking up your pet waste, especially around the coast and on the beaches. While it looks like a little bit of nitrogen in that waste, there's a lot of people with pets, and it adds up. You can, to reduce emissions, these nitrogen emissions, you can do things like carpool, use electric cars. Also, if you're fertilizing your lawn, just like farmers, fertilizer is pretty cheap, so you can overdo it to make sure your yield is good, but you want to keep in mind when you overdo it, that nitrogen has to go somewhere. So reducing this lawn fertilizer on the local level will also help. And with that, this just came out actually, and this is a lot of the same ideas. I just read this about, I guess, 2 days ago, but this is in the Baffin Bay watershed, and it was put out by the Texas Water Resources Institute. And it has a lot of these same ideas that I was just talking about, but it's a watershed protection plan for the Baffin Bay system, which is pretty exciting. And I hope it gets off the ground and accomplishes a lot. But there's a link down here to it. I think you could probably just Google it, but it goes over some of these same ideas that I went over in the last 2 slides. And with that, I'll take some questions.
Dr. Felix, thank you so much for a great presentation. You went in deep there on some topics. I wanted to do a couple of follow-ups and also to invite and remind folks if they have questions or comments to please include those in the chat. In a moment, Christina will help to facilitate some of the chat questions and comments, but I mentioned to ask a couple right here since I don't think we have anything queued up yet. I was wondering if you could help provide some context for the groundwater nitrogen and ammonia. And I was in particular, what would be, so it's called normal or natural levels as compared to what you're observing in some of your plots that you presented earlier?
Yeah, so if we look back to, I don't know if I'll have the concentrations, but I mean, normal levels would be closer, if you could talk more, maybe under 50 micrograms per liter, which is maybe a better term than what I'm showing here in micromolar. It's what we work in. So these Baffin Bay groundwaters, keep in mind, these are superficial groundwaters. They're not down into the confined aquifers. But these are very high in Baffin Bay, where if we look to, here we go, in the Matagorda on the barrier islands, let's see, nitrate is blue here. We want to look at this scale. It's relatively low. A lot of it's, down around underneath 20 micromolar. So these are normal background. Baffin Bay, again, with these averages and these very high values are not normal for nitrate. Now, at the same time, in well waters in Matagorda, these very high ammonium levels are very unusual also. So you would expect maybe it to be the ammonium to be nitrified to nitrate, which I think is happening. So you see a high ammonium and then followed by some high nitrate also here. So coming back to, I quickly mentioned on these barrier islands behind them, is, estuaries, bays. And in bay water, because they're have longer residence time, more buildup of organics, you can actually build up a lot of ammonium in bay pore water. So whether this is representative of maybe that back bay, these high ammonium values, or is it representative of actual a source like septic water, septic effluent, which is high in ammonium leaking into these groundwaters, is something we're trying to get at, differentiate between the two.
Thanks, and that's actually a great segue to another question regarding assimilative capacity and appropriate levels of nitrogen in our bays and estuaries. And as a community of practice, do we understand here in Texas, where the sweet spot, so to speak, for nitrogen levels in our various bays, or is this so specific that it's hard to generalize?
Yeah, it's tough to generalize because even when you think of algal blooms and hypoxia, because I think when you think of a sweet spot would be avoiding that, but also providing nitrogen for primary producers. So it's not just nitrogen. There are physical things happening. There's salinity that affects this. There's also mixing of the water column and temperature that affects this. So a sweet spot for nitrogen also involves all these other factors.
Thank you for that. Christina, do we have some questions in the chat box?
Yes, we do. All right. The first one is there a funding source identified for landowners to tap onto in order to upgrade septic systems?
So, Jason, do you know more about this? I think there are. I know there were sources going through. I don't know about approvals.
If the question's specific from septic into a local wastewater treatment plant, I am not aware of a specific program that provides that. Typically, that responsibility will fall onto the specific property owner. It sounds like a great point of interest and question, though, as typically tapping into the wastewater treatment plant can often bring benefits both to the landowner as well as to our water quality.
Thank y'all for that. I've also heard a little bit of background. There might be some funding coming out soon for the Baffin Bay area on upgrading septic systems specifically, but I think that's all maybe forthcoming.
Yeah, I've heard that too. That's why I wasn't sure the stages.
And yeah, I'm not sure either, but fingers crossed.
Sorry, this is Heather Robinson. I figured I would just chime in on this situation. I work for the non-point source program at TCEQ. And we do fund a lot of these OSSF remediation projects through EPA money. So, and there is one coming out for Baffin Bay as a result of the new WPP that just got accepted. So that's mainly going to be just a pump out and inspection program for now while they get some of their feet on that implementation. But anyway, yeah, so you can check out the non-point source, the TCEQ non-point source website, and that'll give you more information on the septic system programs that we fund.
Thank you so much, Heather. Glad to have you on the call today, to have your expertise straight from the source.
And on that note, if I could just add on to what Heather mentioned, the Nueces River Authority, Texas Water Resource Institute, Houston Galveston area COG also have some similar programs that I believe are also wholly or partially funded through TCEQ.
All right, you ready for the next question, Dr. Felix?
Yes, please.
All right, did you look at the possible additional wastewater contributed by cabins on Baffin Bay that may not be following the sewer regulations?
That is interesting. I think that it's not something we've looked at, but I think you could probably, I don't know how much they're in use, but I think if you kind of had some data on how much they were in use by how many people, and if they aren't following those protocols, then you could get at a loading estimate pretty easy based on the amount of people and time they're there. But it would be tough. There would be probably some self-reporting and also self-tattletaling I guess, saying that we're just dumping this into the bay. So I don't know if we could exactly get at that, but that's a good idea.
Thank you. All right, this next one looks like possibly a two-parter. All right, so in estuaries and bays of South Texas, the N is often very limited if you take a look at NP ratios. And surface waters are often less than a couple micromolar. So my question is, do we really have an N problem? Following on this question, how much N is supplemented through deposition in bays and estuaries in general?
So the N problem depends on where you are in the on the coast, right? If you look at that graph, a lot of people think of an N problem as just inorganic nitrogen, and for the most part, inorganic nitrogen is low across here. I think it's being consumed pretty quickly. But if you look at total nitrogen with the DON that we now know is bioavailable, and you start to realize that this is bioavailable, not only that, the parts that is not directly bioavailable can undergo chemical reactions, photochemistry to make the DON, which is a very large pool, bioavailable. So is it a nitrogen problem? I think if you look at it, especially down in these areas where you have very high nitrogen, yes, it can be a nitrogen problem. Other places, maybe it's limited, but it really depends on the area. And then as far as, I think deposition was the next question.
Yes,
So-
would you like me to repeat the question?
Just the last half, yeah.
Sure. How much N is supplemented through deposition in bays and estuaries in general?
Yeah, so this is something that I wish I had one of my students data in front of me, where she has been looking at the nitrogen deposition as a whole over the last 18 months. And actually we take that rainwater portion, and we actually can parse out the emissions that are using the isotope techniques that are actually getting into that rainwater, all ammonium nitrate and DON. And she has estimates of, how much is probably reaching each watershed just through wet deposition. And now I have another student working on the dry deposition aspect, because people think about deposition, they think water, but it's often dry here. There's no rainwater, but we're still emitting nitrogen from sources, both biogenic and anthropogenic, and it's constantly being deposited into the watersheds and directly into the bay. So what we're trying to do right now is really get at the significance of that deposition. But there are papers that show, in our coastal areas, it can reach up to 30% of the nitrogen loading.
Hey, thank you so much. All right, next question. And this has a little bit of background too. All right, even though you know the isotopic ratio of 4 potential DON sources with just one environmental sample, I'm not sure how you can definitively estimate the ratio of all 4 in that sample. It's somewhat like the one equation and 4 unknowns. Is there other information that you're bringing into the analysis? I think you mentioned a Bayesian approach.
Yeah, so the Bayesian approach is how we get at a best estimate, because yes, there are 4 unknowns, and this is really a best estimate. Before this, we only have concentrations. We're starting to try to piece this apart, and this is the best next step. And then we have a lot of ancillary data. We have other anions, cations, salinity. We have water isotopes also that we're tying all into this. That could be, you can use different ratios. Different sources have different ratios of anions and cations that you could start to piece into these mixing models also, which is kind of the grand goal, is that, and I'm just touching on this one aspect that is complementary to other aspects.
Got it. Well, that's the last of the questions in the chat so far. If you have any outstanding questions, please be sure to put those in the chat now before we wrap things up.
Dr. Felix, how would you characterize our general understanding in Texas, compared to where maybe we should be to make management decisions, looking forward into the future? Do you feel like we have adequate knowledge, or how would you rate where we are in the community of practice?
Well, I think a lot of these questions I've said, we have a big coast, right? And we've been down in Baffin Bay, starting with Dr. Wetz and that volunteer group. And I think they really starting to have a great idea of what's going on down there and what's going on temporally and how it changes with climate. We have all these different factors that aren't just nitrogen, that impact how the nitrogen's getting there. So in areas like that, where we've done these long-term studies, I think they have a pretty good idea. You have these watershed plans coming out that are based on facts that we know about, and they've done a good job. And now I think money needs to go into, all right, what are the fixes? We're getting that way in other areas where we're doing these longer term studies, but I think they're important, everywhere up and down the coast until you can get at these watershed plans. And fortunately for the first plan, everybody else can learn from that plan. And I think they just improve and they improve. And so do our studies, where in the beginning, maybe our studies are broad reaching, but we can start to eliminate and fine tune each study so they're more efficient moving forward for each watershed plan.
Thank you. Christina, do we have any other questions or comments to share?
We do not.
Well, Dr. Felix, we really do appreciate your time and sharing some expertise and digging in deep onto this topic. There's a lot to be learned, and I'm excited I think some of the information is going to continue to steep on me as I continue to digest all of what you shared. So thank you for your time and expertise. Christina and Anna, I want to say thank you for hosting and facilitating with Texas State Meadow Center for Water and the Environment. For more information, please feel free to take a look at the links for the menu of services to see how we may be able to assist your community with enhancing the management of non-point source pollution, and check out our website, cleancoast.texas.gov, for more information on that. Christina.
Thank you all so much for joining us today, and special thank you to Dr. Felix for being our featured speaker. I popped some links into the chat. Feel free to check those out. Like I mentioned in the beginning, this is recorded and we will post a recording when that is ready. Thank you all so much for joining. We sure appreciate it. Have a good rest of your day. Thank you for educating me on water chemistry. I'm a geographer, so I'm like, what? Nitrogen? That was super cool. Thank you.
No problem. And I mean, if anybody contacts you with questions afterwards, just shoot them my email. Sometimes people are a little nervous to reach out in a group,
Yes. Yeah. Hey, I have a question. I was actually too nervous to ask. When you were talking about testing the different types of water, like the surface and the ground and pore, I'm assuming pore is literally like kind of soil, shallow.
Yes.
Okay.
Yes.
Sweet.
Yep.
Yeah, I've just never seen that broken out like that as identified as water sources.
Yeah, I mean, a lot of people think, what's in my surface water? What's in the surface, or even the groundwater? But we spend our whole lives in it, and we're like, we want to see it go the whole way, and that pore water is, that boundary is really important. Yeah.
That's really interesting. Do you think that this has to do, I mean, you mentioned the septic stuff, and I'm asking this because, like I said, I'm a geographer and I do like human environment interaction studies, and I'm going to do an absentee landowner study around the Baffin Bay watershed. We're going to send out a survey and ask people like what conservation practices, if any, they're doing on their land. And I wonder if that might be helpful in a sense, just to get a general idea of like what the overall mindset is of environmental awareness in that watershed.
Well, there's also that, and actually knowing how much they use the houses down there. There's a lot of second homes.
Yes.
So I mean, the septic's not a problem if it's not being used.
Right.
So how much is it really being used? And you can get at a decent estimate if you know how many people are there for how long, how much of the year,
Yeah.
just on, you kind of take people's waste on average and you can kind of say there's this much waste. If it's not being processed well, this is what's reaching the groundwater.
Yeah,
Yeah.
exactly. Okay, cool. Yeah, I'm going to be sharing a summary report with the Baffin Bay group on that. So hopefully that
Okay.
would be helpful in some sense.
I
Well,
think it will.
it was so great to meet you. I sure appreciate it. And I did get to go to the beach yesterday. I got a little sunburn. We were in Rockport for a meeting and we ended up doing like a little site tour. So
Is that your one time a year?
yeah, that was just, the one and done.
Yeah.
No, I do hope to go again. And man, when I got about an hour out of the coast, my allergies immediately ceased and I felt so much better. So maybe I'll plan a weekend trip to help with that. But it was so
Awesome.
great to meet you. Sure appreciate it. Thanks for sharing the slides and going through all the pre-show stuff with us and the checks and double checks. Sure appreciate all that.
Thank you. I'll be happy to
Thanks.
update somewhere down the line.
All right. Sounds good. Take care.
Okay, see ya.
Bye.